It is a m number of inputs and n number of outlets will be there. Here the switching types will be using the magnetizing the cross points. Okay, the matrix of cross point are used to make a switching for this m number of inlet and m number of outlet. That's a single stage. Single stage means the n number of inlet should be connected to the n number of outlets. Okay. The single stage network can also be constructed by multiplying banks of m uniselectors. Okay, or level of group of m two motion selector each having a n inlet. It means that we can make a group. We can make a group of through the uniselectors. Okay. Suppose suppose is m is equal to, suppose number of customer will be 30 will be there. We have only 20 switches means we can make a group. Okay. Two groups 10 10. Okay. Based on that group, based on the uniselectors, we make the connection for the n number of outlets. Okay. And then the further system may employ the photonic switches, in which photoelectronic switches are used to cross point to make the connection between the optical fiber trunks. Nowadays, in modern DSS, what they are using the photonic switches. Still, it is research will be going on related to the photonic switches. Okay, in future, can use this photonic switches. Okay, nowadays, what happened? There's a program controlled switches are there. Okay, there's a program controlled switches, digital switching system are used in the nowadays. Now in future, there is a photonic switches are employed to do this process. In the photoelectronic switches are used to cross point to make the connection between the fiber optics. Okay, fiber optics, and then the above figure is represented the simpler form of the symbol of switches. You can see observe. See, this is a single stage network. Okay, this m will be there, n should be there. It means this is a single stage. Here there's no stages will be there. Okay, there's no group will be there in the single stage network. The below figure used to represent the electromechanical switches. The round mark is there, na? That is the round mark is represented the electromechanical switches. Okay, in earlier days we are using this electromechanical. After the electromechanical, they are introduced the class of matrix switches by using the suitable magnetizing vertical and horizontal magnetic components are used to make the cross connection between the n and m inputs and outputs. Okay, here in this switching single stage network, I'm showing here this m is the number of input and n is the number of output. How they make the connection between the m and n through this electromechanical switches. Through this electromechanical switches, you can see, observe here, the round mark is there. That's the electromechanical switches. This is and then it has some associated control mechanisms. Okay, how to make the connections through some relay. Okay, through some relay signals, they will make the contact between the two input and output. Okay, and crossbar switches give a full availability, number of call lost, no call lost, and then unless outgoing trunk are congested. Okay, instead of using this one, then your next evolution will be the crossbar mechanisms system are adopted. Here there is a fully availability will be there. Okay, full availability will be there. Suppose the n is equal to 5 and m is equal to 5. Number of input is equal to number of output. Suppose 5 means how many cross point will be get it? It is the power of 2. Okay, it means 100 cross point will be available for 10 input and 10 output. Okay, that's why the crossbar switching system have a fully availability, no call cost. There's a no last calls. It is free conjunction. Okay, the number of simultaneous connection will be made. Suppose if m is equal to less than of n. Okay, suppose m is equal to less than of m. Okay, m is the input and n is the output. Okay, m is equal to less than of n, then and n less than of m, then the switch contains mn cross points. Okay, we'll get same multiplication of cross point will get. Suppose m is less than of n or n is less than of m, we'll get mn cross points. So suppose it's nothing but if m is greater than n or n is greater than m, or m is less than of n or n is less than of m, we'll get mn cross points. Okay, mn cross point means we'll get n square. The cross point will be get n square. N square is nothing but n is the output, correct? N is the output. Suppose output will be 10 means we'll get cross point will be a 100 for 10 input. For 10 input, we'll get 100 connections for using this crossbar switching mechanisms. Okay, then by using this, the cost the fixed cost will be goes on increases. The size also will be goes on increases. Okay, because of square. The C is equal to contact cross point C1 is equal to n square, means the size of this system will be goes on increases, and cost also will be increases because of a number of increases. Number of cross point will be a square of the output, square of the outputs. And where efficiency proportional to the cross point, there's n by n2, that's equal to 1 by n, decreases inversely with output. Okay, decreases with output. Decreases with output means the output will be increases, efficiency will be decreases, efficiency will be increases, output will be decreases. Because of we are considering how to identify the efficiency, means based on this economic cost, everything we should consider. Okay, that's why the efficiency will be decreases with the inverse of n. Okay, clear? N by n square. N, okay, see there's a equation is given here, n divided by n square. Okay, n is the input, we'll get the cross point will be n square, then 1 by n will get it. The efficiency is efficiency is inversely proportional to the n. Okay. Then we are given one example here. You can see, observe in this slide. It is uneconomic. It is uneconomic to use this single stage for large number of inlets and outlets. It is not economical. Okay, because of the network size will be goes on increases, and then the cost will be goes on increases. Clear? Any doubt regarding this? It is audible, dear student. It is audible.
Yes, sir.
The presentation is visible.
Yes, sir.
Okay. Because of this kind of connections cross point, it is cost will be goes on increases, number of switches also will goes on increases, and size of the system will be goes on increases. Okay. Suppose we have given an example here, the switch of 100 inlets. The inlets will be hundreds, and outlets requires how many? 100 into 100 will be 1000. 10,000 crosspoint will be there. Okay, 1, 2, 3, 4, 10,000 crosspoint. For 100 in input, we'll get how many? 10,000 crosspoint. Suppose we can take an example, 10 inlet means how many crosspoint will get? 10 square is equal to 100 crosspoint. See, in that totally 10,000 crosspoint, we can use only 1% of the crosspoint can use at a particular time. At any time, we can use only 1% of crosspoints. Okay, then the remaining 99% of crosspoint will be waste only now. They are not using. Okay, because of we have only 100. We have only 100 inlet, but we have how many crosspoint will be generated by using this crossbar matrix? We'll get 10,000 crosspoint. Only we are using only 1% of this. 1% of the connections crosspoints are used at any time. Okay, that's why it is uneconomic. Okay, switches for making the connection between the large number of trunks are therefore constructed a network containing a several stage of the switcher. Then we go for this to avoid these kind of connections. Then we'll go for the some stages. They will make some group. Okay, suppose is I will next slide will be I'll show that one. Suppose is 100 input will be there. We have only 50 outlets will be there. All the 50 will be will make a group, and each in the 50 some of the lines will be interconnected with some other group also. Okay, that way we can reduce the number of cross points, outlets, and we can use efficiently. Okay, that's why they introduced some of the several stages of the networking system. Then the operation of crosspoint coordinator GK to connect the inlet J to outlet K. Thus perform the same function as operating of crosspoint K into J to connect inlet K and outlet J. Suppose nothing but in that crossbar mechanism, if suppose the coordinate 2 points will be there. Suppose you consider 2 points will be J and K. If you make the connections between inlet to outlet K, the same performance also will be can operate it from K to J. Means for one connection we are using the 4 different manners. Okay, so that half of the crosspoint are redundant by using these connections. That's why in the diagonal in the matrix crosspoint matrix, we can reduce the half of the crosspoints. Yeah, clear about this one? Suppose if there is a 2 coordinators will be there, J and K coordinates points. If you connect those 2 points through this connect the J inlet J to outlet K, and then same performance, the same connection will be done by operating the cross point K to J. Okay, K to J. Okay, that's why what they did means they're removing the half of the cross matrix. They'll redundant means they remove the half of the cross point. Okay, that will be nothing but it's eliminating. Okay, then we'll get this kind of number. The resulting, they will get the triangular cross point matrix as shown in the figure. See, some half portion of diagonal matrix will be removed, remaining half will be there. Okay, the number of cross point is required. Then it will be reduced to half. Okay, then C1 is equal to half 1 by 2 into n minus 1. Suppose n is equal to take 10. Okay, 10. Okay, 10 minus 1 is 9. Okay, 10 minus 1 is equal to 9. 9 into 10, 90. Okay, divided by 2, 45. Okay, then it is reduced. Half will be reduced. C1 is equal to, will get 45 for this kind of configuration. In earlier is equal to C1 is equal to n square. For 10 input, how many will get? 100 switches will get it. Now it will be reduced to half. We'll get suppose 10 is equal to the outlet will be a 10. 10 and the consider 10 minus 1, 9. 9 into 10, 90 divided by 2 will get 45. Cross point will get for 10 outlets. Okay, reduced to half. Okay, okay, that is called as a this kind of configuration is called as a triangular switchers. Okay, here also they are not used fully. Okay, andre ಏನಪ್ಪ ಅಂದ್ರೆ ಎಷ್ಟು in remaining 45 ಇದೆಯಲ್ಲ ಆ 45 ನು ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ. Okay, the triangular switches are not fully usually found in the telephone exchange because both way trunk are not used. Okay, then trunk are operated on one way basis for to facilitation of supervision. Then they're introducing the grading mechanisms. So the grading, okay, this kind of mechanisms are introduced in the telephone networking system. Okay, they will make the group. Okay, each trunk line will be connected by through a uniselectors in the particular groups. Okay, that is called as a grading. Here, for a route switch or concentrator, it is not necessary for each incoming trunk to have access to every outgoing trunk. Okay, in lane ಅಂತ ಬರುತ್ತೆ ಈ ರೂಟಿಂಗ್ ಸ್ವಿಚಿಂಗ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಒಂದು ಇನ್ಪುಟ್ ಇನ್ನೊಂದು ಔಟ್ಪುಟ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ಏನಿಲ್ಲ. ಓಕೆ, ದೇರ್ಸ್ ನೋ ಮೀನ್ಸ್ ಈಗ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಸಪೋಸ್ ಒನ್ ಇನ್ಪುಟ್ ಇಲ್ಬಿದೆ ಫಾರ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಇನ್ಪುಟ್ ಗೆ ಒಂದು ಔಟ್ಪುಟ್ ಇರಲೇಬೇಕು ಅನ್ನೋದು ಏನಿಲ್ಲ. ಓಕೆ, ದಿಸ್ ನಾಟ್ ನೆಸೆಸರಿ ಫಾರ್ ಹ್ಯಾವಿಂಗ್ ಎ ಎವ್ರಿ outgoing trunks for every incoming trunks. Okay, it is not necessary. It is not necessary for each incoming trunk I have to access to every outgoing trunk. It is adequate if each incoming trunk has access to sufficient number of trunks. Okay, we'll give some adequate trunk lengths for each incoming trunk by rearranging the by different stage of networking. Okay, inadequate if each incoming trunk have access to sufficient number of trunks on each routes to give required grade of services. This is called as a limited availability. The number of outgoing group. Okay, you can see, observe the next we go for this one. The number of outgoing groups, the number of outgoing trunks to which an incoming trunk can be obtained. Connection called as a fully availability. Okay, and corresponding outlet capacity of the switch are used. Okay, then we can see, observe, this is a grading mechanisms we are adapting in the system. Okay, you can see, we can observe we have 20 trunks lines will be there. So you can see, observe, we have 20 trunks on outgoing route to which incoming trunks have a access by means of switching, giving the availability of 10 only. Okay, see, totally there is a totally 20 trunks lines will be there. Okay, see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These are 10 outgoing group or 10 outgoing lines. Will make a group 2 and 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. This odd number will be there. Na? The odd number 10 lines will be make a group 1. Even number of 10 lines will be make a group 2. Okay, there is a 20 trunks connected in a 2 separate group of switches. Availability will be 10. ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಎರಡು ಗ್ರೂಪ್ ಟೋಟಲಿ 20 ಟ್ರಂಕ್ಸ್ ಲೈನ್ ಇದೆ. ಈ 20 ಟ್ರಂಕ್ ಲೈನ್ ನಾವೇನ್ ಮಾಡ್ತಿದ್ವಿ, 2 ಗ್ರೂಪ್ ಆಗಿ ನಾವು ಸಪರೇಟ್ ಮಾಡಿದೀವಿ. ಓಕೆ, even number of lines will be make a one group, that's a group number 2. Odd number of lines will be make a group will be 1. Okay, each group we have 10 lines are there. Okay, suppose you can see in the figure group 1 and group 2, how many number of trunk lines will be there? 10 will be there. Okay, like that we have separate the trunk lines with the different groups. That's why in the below figure we can see there is a showing a 20 trunks of an outgoing route to which incoming trunk are accessed by means of switching, giving an availability of only 10. Okay, nearly we will get totally 20 outgoing trunks will be there, but each group we are connecting each group incoming trunks have access by means of switching, giving an availability of 10 only. Okay, and also we can see in the figure the outlet of switches are multiplied together in a 2 separate group, and 10 outgoing trunks are allocated by each group. Okay, in each group there is a 10 outgoing trunks lines are allocated for each group. Okay, we can see observe in the figure also group 1 and group 2. Okay, clear. Then suppose if the total traffic covered by this incoming trunk will be 8e. Okay, suppose you can consider for this kind of grouping outlet trunks, suppose we are affording nearly 8 Erlangs, each group of outgoing trunk offered by 4 Erlangs, and then what is the grade of services will be better than 0.01. Okay, it means that suppose in this group, okay, in this group we have 2 group is there now for 10 trunks lines. Suppose the incoming lines, okay, the total offered by the incoming trunk. So take an example by using the formula, there's a E is equal to A is equal to traffic, A is equal to CH by T. Okay, using that formula we are assuming that that's it. Okay, what is suppose the total number of traffic offered, incoming traffic offered, is 8e, and each group of tracking, each group of traffic offered, outgoing traffic offered will be 4e. Then what is the grade of service should be a 0.01 will get. Andre ಏನಪ್ಪ ಅಂದ್ರೆ 8 ಲೈನ್ ಗೆ 8 ಇನ್ಕಮಿಂಗ್ ಲೈನ್ ಗೆ ನಾವು 4 ಔಟ್ಗೋಯಿಂಗ್ ಕೊಟ್ರುವೆ ಗ್ರೇಡ್ ಆಫ್ ಸರ್ವಿಸ್ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ 0.01 is a better grade of services. Okay, for that mechanism only, for that calculation only, for 20 lines we make the 2 groups. Okay, it means that each group having a 10 incoming lines, 10 outgoing lines. You can access each group, each incoming lines. Okay, then if the traffic offered by 2 groups, incoming trunk is random, peak loads will seldom occur simultaneously for 2 group. The efficiency can therefore be improved by through mixing of the traffic by interconnecting the multiple of 2 groups, so that same of the outgoing trunks are available for both a group of switches. Okay, it means that suppose again madi andre suppose we have 10 outgoing lines and 10 incoming lines irutte. Okay, now group madidru enagutte, suppose all the customer will make the connection, means all the groups will, all the trunk lines will be engaged with a particular incoming lines. Okay, ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಈಗ ಏನಾಗುತ್ತೆ, ಈಗ ಇನ್ ಗ್ರೂಪ್ 2, ಈ ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ ಏನಾಗ್ತಿರುತ್ತೆ, ಇನ್ ಸೇಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, there is no connections, there is no connection, there is no incoming or outgoing lines ಇರೋದಿಲ್ಲ. ಅವಾಗ ಏನಾಗುತ್ತೆ, will be some group 2 will be free ಇರುತ್ತೆ, ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ busy ಇರುತ್ತೆ. Okay, suppose ಏನ್ ಮಾಡೋಣ ಅಂದ್ರೆ some of the lines should be interconnected with group 1, group 2. Okay, suppose here there is in group 1 there is a more traffic will be appeared in the particular time duration ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, what will you do means the connection will be shifted to the group 2 through interconnecting the trunk lines. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಅಂದ್ರೆ ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ ಟ್ರಾಫಿಕ್ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಆ ಗ್ರೂಪ್ 1 ಇರೋಂತ ಇನ್ಕಮಿಂಗ್ ಲೈನ್ ನಾವು ಗ್ರೂಪ್ 2 ಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೀವಿ ಥ್ರೂ ದ ಇಂಟರ್ ಕನೆಕ್ಷನ್ ಆಫ್ ದಿ ಸಮ್ ಆಫ್ ದ ಟ್ರಂಕ್ಸ್ ಲೈನ್ಸ್. Okay, that mechanism we are used to reduce the you can increase the efficiency, and we should give the reliability of the connection for the all the customers. See, you can see, observe here. This is the arrangement we have given here. This is the arrangement given. See, in this arrangement, we can see in this arrangement the first, see, group 1, group 2. Group 1, how many trunk lines will be there? 10 will be there. Group 2 will be the another 10 lines will be there. 10 trunk line will be there. In the first group, okay, in the first group, the first 6 outlets, the first 6 outlets is 1, 2, 3, 4, 1, 3, 5, 7, 9, and 11. Okay, these 6 outlets are in 2 separate fully availability groups. Okay, these 6 lines will be fully availability groups. It's nothing but there is no interconnections. Okay, for group 1 incoming lines ge all these 3, 6 for dedicated lines for group 1 incoming lines. Okay, and the last 4 outlets is there. No, there is a last 4 outlets. Okay, like 11 admile enide 13, 15 and 17 and 19. Okay, another 4 lines. That another 4 lines will be common for the group 1 and group 2. Okay, group 1 and group 2. Similarly, in case of in group 2 also, the first 6 lines 2, 4, 6, 8, 10 and 12. These 6 lines are dedicated to the group 2 incoming customer. It is a fully availability. Fully availability ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ ಯಾವ್ದು ಬರುತ್ತಲ್ಲ ಇನ್ಕಮಿಂಗ್ ಲೈನ್ಸ್ ಅದು ಈ ಲೈನ್ಸ್ ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ. There is a fully availability. Another 4 will be common for both group 1 and group 2 trunks lines. You can see, observe, there is a connection between there. Okay, 13, 14, 15 and 16. Okay, these 4 groups are the common for group 2 and group 1. Okay, you can observe here in this figure. Okay, and 13 line number 13, 14 and 15 and 16. Okay, these 4 trunk lines are the common for both group 2 and group 1. Okay, they will share the lines. It will be share this trunk lines. These 4 will be share the trunk lines between the group 1 and group 2. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Clear about this one? See, once again I repeat that there is a 2 groups will be there. Each groups having a 20 trunk lines will be there. Okay, in the 20 there is a 10 trunk lines are there for each group. Okay, group 1 and group 2. Totally we have 20 trunk lines are there. Okay, these 20 trunk lines are will be separated into 2 groups. Okay, each group will be 10 trunk lines will be there. Okay, then for increasing the grade of service, what we are doing here, for group 1, first 6 lanes the dedicated for the group 1 customer, means group 1 income is a fully availability. Fully availability means the group 1 incoming line is directly connected these 6 lines. It is a fully availability lines for the particular group 1 users or group 1 incoming trunks. Okay, another 4 and similarly for group 2 also, for 6 trunk lines will be fully availability for group 2 customers. Okay, and another 4 of the group 1 and another 4 of group 2. Both trunk lines are common for the both the trunk lines are interconnected. Okay, and then these 3-4 lines are common for group 1 and group 2. Okay, ಅರ್ಥ ಆಗ್ತದೆ, common for group 1 group 2. Suppose ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಯಾವ ತರ ಹೇಳ್ಬೋದು ಅಂದ್ರೆ, see, ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ 20 ಇನ್ಕಮಿಂಗ್ ಲೈನ್ಸ್ ಇರುತ್ತೆ, ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ 20 ಇನ್ಕಮಿಂಗ್ ಲೈನ್ಸ್ ಇರುತ್ತೆ. ಬಟ್ ಔಟ್ಗೋಯಿಂಗ್ ಟ್ರಾನ್ಸ್ ಲೈನ್ ಏನಿದೆ ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ 10 ಇದೆ, group 2 will be 10 ಇದೆ. ಓಕೆನಾ? ಕ್ಲಿಯರ್? ಸಿ ಸಪೋಸ್ ಸಮ್ ಟೈಮ್ ಏನಾಗುತ್ತೆ, ಗ್ರೂಪ್ 1 ನಲ್ಲಿ 14 ಕಸ್ಟಮರ್ ಆರ್ ಮೋರ್ ದೆನ್ 10 ಕಸ್ಟಮರ್ ಕಾಲ್ ಮಾಡೋದಿಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಓಕೆ, ಅಂಡ್ ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಓನ್ಲಿ 5 ಕಸ್ಟಮರ್ ಕಾಲ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಓಕೆ, ಇನ್ ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ 5 ಕಸ್ಟಮರ್ ಕಾಲ್ ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ ವಿ ಹಾವ್ ಎ ಡೆಡಿಕೇಟೆಡ್ ಫುಲ್ಲಿ ಅವೈಲಬಲ್ ಲೈನ್ಸ್ 6 will be there. Those 5 lines will be directly connected to the particular group 2 customers. Okay, and then in group 1 ಅಲ್ಲಿ 12 customers connect ಮಾಡ್ತಾ ಇರ್ತಾರೆ, but we have only trunk, we have only 10 trunk lines will be there. Okay, ನಮ್ಮ ಹತ್ರ ಏನಿದೆ 10 trunk line ಇದೆ. Okay, but at particular time ಅಲ್ಲಿ nearly 10 to 12 or 13 customers ನಮ್ಗೆ ಕಾಲ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಓಕೆ, ಅವಾಗ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ 6 can for the 6 will be availability for group 1. See, another 4 will be also availability for the availability of common, means shared between the group 1 and other shared between the group 2. Okay, ಅಂದ್ರೆ ಇಲ್ಲಿ 10 4 ಕನೆಕ್ಟ್ ಆಗಿ ಮತ್ತೆ ರಿಮೈನಿಂಗ್ 4 ಮೆಂಬರ್ಸ್ ನಾವು ಗ್ರೂಪ್ 2 ಇನ್ಕಮ್ ಟ್ರಂಕ್ ಲೈನ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಕನೆಕ್ಟಿವಿಟಿ ಕೊಡ್ತಾ ಇದೀವಿ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆ? ದಟ್ಸ್ ವೈ ದಿಸ್ ಕಾಮನ್ ಫಾರ್ ಬೋತ್ ದ ಲೈನ್ಸ್. ಓಕೆ, ಕ್ಲಿಯರ್? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ? ಸರ್ ಇನ್ನೊಂದ್ಸಲಿ ಹೇಳ್ತೀನಿ ಕೇಳಿ. ವೆರಿ ಸಿಂಪಲ್. ಅಂದ್ರೆ using this kind of connections we can easily distribute the work from the workload for different groups. Okay, workload na ನಾವು ಈಸಿಯಾಗಿ ನಾವು ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಬಹುದು. ಅರ್ಥ ಆಗ್ತಾ ಇದೆ? ಫ್ರಮ್ ದಿಸ್ ಟೈಪ್ ಆಫ್ ಕಾನ್ಫಿಗರೇಷನ್. Okay, clear? Any doubt regarding this?
No, sir.
Yeah. See, ಇನ್ನೊಂದ್ಸಲಿ ಹೇಳ್ತೀನಿ ನೋಡಿ ನಿಮ್ಗೆ, ಇನ್ನೊಂದ್ಸಲಿ ಅರ್ಥ ಆಗ್ಬೇಕು ಅಂದ್ರೆ, see, grading is nothing but there is a interconnection between the groups. Okay, interconnection of the trunk based on the principle of grading. Okay, that is called as a GOS. GOS is the grading of service. The arrangement of require only extra outgoing trunk for the same GOS. The technique of interconnecting the multiple of switches is called as a grading. Okay, there's a multiple switches. See, here group 1 4 trunks and group 2 4 trunks, both are interconnected. Okay, that way can called as a grading. That is called as a grading. Okay, this technique of interconnecting the multiple of switches is called as a grading, and interconnection of trunk based on the principle is called as a grading. Okay, the grading is enable a single switch stage, the single switch stage to provide the access to number of trunks greater than the availability. ಔಟ್ಪುಟ್ ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ನಾವೇನ್ ಮಾಡೋದು, ಅನದರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇರೋಂತ ಲೈನ್ಸ್ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಕನೆಕ್ಟಿವಿಟಿ ಕೊಡ್ಬೋದು ಅಂತ ಅರ್ಥ. ಓಕೆ, okay, don't worry about this one. We have solved some problem related to this grading services. We'll get to know that. Okay, a grading provides a proper grade of services, then fully availability group for same number of trunks. Some lost calls occurs even when there are free outgoing trunks, when these trunks are part of the grading which is not accessible to the group of selector containing the incoming group requiring the connections. Okay, these grading are called as a ODEL grading. Okay, they are the most widely used for the grading in the class of grading known as a progressive grading. In progressive grading, the switches untoward the outlet sequential from the fixed home position. Okay, see, ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ, ಈಗ ನಮ್ಮಲ್ಲಿ ಏನಾರ ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ ಟ್ರಾಫಿಕ್ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರಾಗ ಏನ್ ಮಾಡ್ತೀವಿ, some line will be shared to the another group 2. Okay, then we can we can utilize fully. All the lines should be utilized properly by proper connection, proper grading between the number of groups. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಅಂದ್ರೆ ನಮ್ಮ 20 ಲೈನ್ಸ್ ಅಲ್ಲೇ ನಾವು ಎಲ್ಲಾ ತರದ್ದು ಪ್ರಾಪರ್ ಆಗಿ ನಾವು ಯುಟಿಲೈಸ್ ಮಾಡಬಹುದು ಈ ತರ ಗ್ರೂಪಿಂಗ್ ಮಾಡಿದ್ರೆ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಕ್ಲಿಯರ್ about this one? Any doubt regarding this? Any doubt? If any doubt, now only if you any doubt, please ask me any question.
No, sir.
ಸಿ ವೆರಿ ಸಿಂಪಲ್. ಅಂದ್ರೆ ಇನ್ನೊಂದ್ಸಲಿ ಜನರಲ್ ಆಗಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ, ನಾವು ಗ್ರೈಂಡಿಂಗ್ ಏನಕ್ಕೆ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, ಸಿ ಇನ್ ಟೆಲಿಫೋನ್ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ ಅಂದ್ರೆ, in the particular telephone exchanges ಅಲ್ಲಿ we have some lines are available, dedicated lines are available. Okay, all dedicated available ಏನ್ ಅವೈಲಬಿಲಿಟಿ ಲೈನ್ಸ್ ಇರುತ್ತಲ್ಲ, ಎಲ್ಲಾ ಲೈನ್ಸ್ in a particular time duration ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಲ್ಲ, because of the progressive calls will be varied with the time. Okay, in a busy hours, in a some days, some special days, the traffic will be appear. Okay, that traffic, how to maintain that particular traffic means by shifting the lines to other group trunk lines. Okay, like that we are doing the grading. We just shift to the that busy line to the another group to make the connections. Okay, that's why we are using the grading system. Okay, okay, clear about this one?
Yes, sir.
If any doubt, see ನಿಮ್ಗೆ ಗೊತ್ತಾಗ್ತಾ ಇದೆ ಇದೇನ್ ಸರ್ ಇದು ಗ್ರೇಡಿಂಗ್ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ನಿಮ್ಗಿದ್ರೆ ಇನ್ನೊಂದ್ಸಲಿ ಕೇಳಿ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಓಕೆನಾ? ಇನ್ ದ ಫಿಗರ್ ವಿ ಕ್ಯಾನ್ ಸಿ ಹಿಯರ್, ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಫಿಗರ್, ಏನಪ್ಪಾ ಅಂದ್ರೆ ಫುಲ್ ಯುಟಿಲೈಸೇಷನ್ ಆಗ್ಬೇಕು. ಈಗ ನಾವು ಇನ್ ದ ಪ್ರೀವಿಯಸ್ ಅಲ್ಲಿ ಏನಾಗ್ತಿತ್ತು, 10 ಟ್ರಂಕ್ಸ್ ಲೈನ್ಸ್ ಗೆ ಎಷ್ಟು ಸ್ವಿಚಸ್ ಬರ್ತಿತ್ತು, 100 ಸ್ವಿಚಸ್ ಬರ್ತಾ ಇತ್ತು. ಬಟ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ 1% ಆಫ್ ದಟ್ ಒನ್ ಅಲ್ವಾ? ಅಂದ್ರೆ 10 ಲೈನ್ ಗೆ 10 ಸ್ವಿಚಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ದು, ನಾಟ್ 100 ಸ್ವಿಚಸ್ ಯೂಸ್ ಮಾಡ್ತಾನಲ್ಲ. ಟು ಅವಾಯ್ಡ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದ ಗ್ರೇಡಿಂಗ್ ಮೆಕ್ಯಾನಿಸಮ್. ಅಂದ್ರೆ ನಮ್ ಮಿನಿಮಮ್ ಸ್ವಿಚಸ್ ಅಲ್ಲಿ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅವೈಲಬಿಲಿಟಿನ ಕೊಡ್ಬೇಕು. ಯಾವ ತರ ಕೊಡ್ಬೇಕು ಅಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಗ್ರೇಡಿಂಗ್ ಮೆಕ್ಯಾನಿಸಮ್. ಓಕೆ, the PPT is available. PPT presentation ಇದೆಯಾ?
No, sir. No, ಕಾಣಿಸ್ತಿಲ್ಲ ಸರ್.
Okay. Okay, that for that purpose we are using this grading mechanisms. ಅಂದ್ರೆ ನಮ್ಗೆ ಮಿನಿಮಮ್ ಟ್ರಂಕ್ಸ್ ಲೈನ್ ನಲ್ಲೇ ನಾವು ಮ್ಯಾಕ್ಸಿಮಮ್ ಫೆಸಿಲಿಟೀಸ್ ನ ಕೊಡಬಹುದು ಅಂತ ಅರ್ಥ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಕ್ಲಿಯರ್? Next we are there is some derivation is there. See there is a progressive grading. Okay, what we are showing the connection now, the grading connection, there is a progressive grading. Okay, and then using this, what is the efficiency? ಅಂದ್ರೆ ನಮ್ಗೆ ಗ್ರೇಡಿಂಗ್ ಅನ್ನೋದು ಯಾವ ತರ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀವಿ ಮೀನ್ಸ್, ನಾನು ಇಲ್ಲಿ ಹೇಳ್ತೇನೆ 4 ಲೈನ್ಸ್ ಮಾತ್ರ ಕನೆಕ್ಟ್ ಮಾಡಿ ನಿಮ್ಗೆ ಅವೈಲಬಿಲಿಟಿ, ನಿಮ್ಗೆ ಗ್ರೇಡಿಂಗ್ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತೇನೆ. ಬಟ್ ಹೌ ಟು ಐಡೆಂಟಿಫೈ ದ 4 ಲೈನ್ಸ್, ಯಾವ ತರ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ, ಯಾವ ತರ ಗ್ರೇಡಿಂಗ್ ನ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ ಅನ್ನೋದನ್ನ we are deriving that is called as a progressive grading. Okay, that should do you should calculate those things, how to means which line should be interconnected. Okay, is a 4 line interconnect ಮಾಡಬೇಕು, ಇಲ್ಲ 5 lines interconnect ಮಾಡಬೇಕು, ಇಲ್ಲ 6 line interconnect ಮಾಡಬೇಕು ಅನ್ನೋದು ಯಾವ ತರ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀವಿ ಅನ್ನೋದಕ್ಕೆ we are designing a mathematical formulas that is called as a progressive grading. Using some formula, we can calculate the grading. Grading is nothing but grading means interconnection between the trunk lines. Okay, in generally we can tell about there is an interconnection between the trunk lines, that is called as a grading. But interconnection ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಲೈನ್ interconnection ಮಾಡಬೇಕು? For 20 line either 4 is right, 4 lines interconnection ಮಾಡಿದ್ರೆ efficiency grade of service ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ, ಇಲ್ಲ 6 lines interconnection ಮಾಡಿದ್ರೆ efficiency ಚೆನ್ನಾಗಿ ಬರುತ್ತೋ, ಗ್ರೇಡಿಂಗ್ ಸರ್ವಿಸಸ್ ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು by using this progressive grading. Okay, design of progressive grading. Okay, clear? ಹಲೋ, ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಹೇಳ್ತಾ ಇರೋದು? yes sir, no?
Yes, sir.
ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ನಾವು ಗ್ರೇಡಿಂಗ್ ನ ಯಾವ ತರ ಮಾಡ್ತೀವಿ, ಐದರ್ ಗ್ರೇಡಿಂಗ್ ಅಂದ್ರೆ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಲೈನ್ಸ್ ನ ಇಂಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ ಗ್ರೂಪ್ ಅಲ್ಲಿ. ಈಗ here 2 groups is there, I am showing that there is a 2 groups is there, each groups will be 10 lines will be there. Okay, and then in the each group 6 lanes for dedicated for the group 1 customer. Another 4 will be make a grading. Again, similarly in the group 2 also 6 lane will be fully available for the group 2 customers. Another 4 from the group 1 and one more group 1, another 4 will be, both are interconnected. Then we can observe here, initially it is a 20 lines will be there. Now for this we can reduce the number of trunks and lines also will be there. Now we can reduce the number of trunks and all will be reduced. Alva, initially 20 iddu, ಈಗ ಎಷ್ಟು trunk line ಇದೆ, 16 trunk lines will be there. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Clear? We can see, we can count that one. Okay, 1 2 3 4 5 6 6 6 12 12 plus 4 16. Okay, by adapting this grading system, we can reduce the trunk lines also. Okay, we can reduce the trunk lines also. Okay, the same services we have given by using this 16 trunk lines. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ನಾವು ಗ್ರೇಡಿಂಗ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗ್ತಿದೆ, ನಂಬರ್ ಆಫ್ ಟ್ರಂಕ್ಸ್ ಲೈನ್ ನಾವು ರೆಡ್ಯೂಸ್ ಮಾಡಬಹುದು. ಓಕೆ, ರೆಡ್ಯೂಸ್ ಮಾಡಿದೀವಿ. ಯು ಕ್ಯಾನ್ ಸಿ ಅಬ್ಸರ್ವ್ ಇನ್ ದ diagram. Okay, 4 4 6 6 will be there for group 1. For 6 trunk lines will be available for the group 1, and group 2 also the first 6 lines will be available for the group 2, and remaining 4 will be the 4 lines will, both will be 4 lines will be interconnected. Okay, another 4 lines will be interconnected from group 1 4 and group 2 4 will be, both are interconnected, is nothing but the 4 will be eliminated. Okay, total number of trunks will be 16. Okay, if you go for that, that's why you should go for the proper grading. We can reduce the number of trunk lines. We can reduce the number of trunk lines. Then automatically the cost of the telecommunication system will be reduced. Okay, within this 16 trunk lines, we can give the sufficient connection for the customers. Okay, ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಅರ್ಥ ಆಗ್ತಿದೆ ಇಲ್ವಾ ಹೇಳಿ, ಸೇರ್ ಸರ್. ನಾವು ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ ನೋಡಿ. ಸಪೋಸ್ 10 ಕಸ್ಟಮರ್, ಈಗ ನಮ್ಮ ಹತ್ರ ಗ್ರೂಪ್ 1 ಅಲ್ಲಿ 10 ಕಸ್ಟಮರ್ ಇರ್ತಾರೆ, ಗ್ರೂಪ್ 2 ಅಲ್ಲಿ 10 ಕಸ್ಟಮರ್ ಇರ್ತಾರೆ. ಟೋಟಲಿ ನಮ್ಗೆ ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ? 20 ಟ್ರಂಕ್ಸ್ ಲೈನ್ಸ್ ಬರ್ಬೇಕಾಗತ್ತೆ. ಓಕೆ, ನಾವು ಈ ತರ ಗ್ರೇಡಿಂಗ್ ಮಾಡಿರ್ತೀವಿ. ಓಕೆ, ನಾವು ಈ ತರ ಗ್ರೇಡಿಂಗ್ ಮಾಡಿರ್ತೀವಿ. ಯಾವ ತರ 2 ಗ್ರೂಪ್ ಗ್ರೇಡಿಂಗ್ ಮಾಡ್ತೀವಿ. ಇನಿಷಿಯಲಿ ಫಸ್ಟ್ ನಾವು ಯಾವ ತರ ಗ್ರೇಡಿಂಗ್ ಮಾಡಿದ್ದು? ಓಕೆ, total 20 10 lines for the group 1, another 10 lines will be group 2. Okay, it means first 10 lines will be dedicated for the group 2 customers, and for another 10 will be dedicated for the group 1 customer. Okay, here we are using a totally 20 trunks lines. After we are doing the grading, the number of lines will be reduced. We can see, observe the group 1, we have 10 customer is there in the group 1. All the group 1 10 customer also can sufficiently connected the 10 outgoing trunks. Alva, andre 4 will be 6 will be fully available for group 1. Another 4 customer can access through group 2 links, group 2 trunks lines. Okay, ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Likewise in group 2 ಅಷ್ಟೇ 6 will be dedicated for the group 2 lines, and another 4 will be interconnected with the group 1. It means you can see in the both the groups the availability lines will be 10 only. ಅಲ್ವಾ, ಇಂಟರ್ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರುವೆ ನಮ್ಗೆ ಏನಾಗ್ತೈತೆ, ಗ್ರೂಪ್ 2 ಅಲ್ಲೂ ಅಷ್ಟೇ ಅವೈಲಬಿಲಿಟಿ ಲೈನ್ಸ್ ಸಿಗ್ತಾ ಇರೋದು 10, ಗ್ರೂಪ್ 1 ಅಲ್ಲೂ ಅಷ್ಟೇ ಅವೈಲಬಿಲಿಟಿ ಲೈನ್ಸ್ ಸಿಗ್ತಾ ಇರೋದು 10. ಬಟ್ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಟ್ರಂಕ್ಸ್ ಲೈನ್ಸ್ ವಿಲ್ ಬಿ 16. ಅಂದ್ರೆ 16 ನಲ್ಲಿ we can easily modify the means we can interconnect the some of the lines, then we'll get fully availability of the group 1 lines will be 10. Also availability of the group 1 lines will be 10 only. In the by using the 16 trunk lines, we'll get like this 10 trunk lines will get it from this grading mechanisms. ಅರ್ಥ ಆಗ್ತದೆ ಅಂದ್ರೆ 16 trunks line ಅಲ್ಲೇ we can easily get the 10 outgoing trunks. Here we are doing the 4 lines, we are making the interconnections. So 4 trunks lines will connect between the 2 groups, connection between the 2 groups. Okay, like that we can reduce the number of trunk line. We can use the proper grading mechanisms. Okay, and we can reduce the cost of the system. Okay, and also reduce the structure of the system. Okay, clear? Okay, dear students, today we'll stop here. Today we'll stop here. We'll continue the next class. Then attendance. Okay, as usual, morning ಯಾರು ಕಳಿಸಿದ್ರೆ attendance ಈಗಲೂ attendance ಕಳಿಸಿ. Okay, clear?
Okay, sir.
Yes.
Okay. Okay, thank you. Okay, and then one more
Thank you,
announcement
sir.
is there. Those who are not paid the college fees, at least you paid the 60% of college fees. Okay, in this month from 28th, second day will start. Okay, on or before second day, everyone should pay the fees. Okay, those who are scholarship, no issues about the scholarship. Okay, Iga Ramesh is there now. Ramesh, we have
Yes,
a
sir.
scholarship amount will be some 59 to 60,000, but your
Okay.
fees will be nearly something. Remaining amount should be pay. Okay,
Okay.
scholarship
Okay.
amount bitte remaining amount pay ಮಾಡಿರ್ಬೇಕು this week ಒಳಗಡೆ.
ಹಾ.
Okay.
sir.
Okay, appa. Okay. Okay. Thank you all. We'll continue the next class. Okay. Send the attendance list.
Okay,
Okay.
sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay. Thank you all.